power cord though. Fortunately, I have to keep my computer plugged in. Okay, happy Monday, everybody. We have a little bit of a different change of class today. I've asked Dr. Chris Wentworth and then in a little bit Dr. Joel Tremont to come and give a presentation. Chris is a physicist who's been on staff for basically ever, as far as we're concerned. And he is one of the members of the physics and engineering department, so I will hand you the mic and let you talk for yourself.
Okie dokie. Well, thank you very much. So first of all, I'm really happy to have a chance to see all of these energetic young first-year students. I think most of you are probably first-year students, right? Okay. Well, as Cale said, my name is Chris Wentworth. Maybe you should see my face. There's a message on here. The battery has failed.
Oh, yeah.
Okay.
I have to ignore my computer sends up random.
Oh, okay. So anyway, as Cale said, my name is Chris Wentworth, and I'm professor of physics here at Doane. And I came to Doane in 1989, and I think that means I'm in my 31st year, if my arithmetic is correct. And that probably makes me one of the longest serving faculty members currently on the faculty at Doane. I won't say the longest, but certainly it's up there among the longest. During that time, I've lived in Crete the whole time, and in fact, I've lived in the same house for that whole time. It's about 5 blocks from campus. Do you know where the city library is? Okay, so I live kind of diagonally across from the city library. You just look for the, everyone's got a nice lawn except for me. I've got, I get cited by the city regularly for not paying attention to my lawn. So I'm not proud of the fact, but that's the way it is. So I've lived, like I said, I've lived here since I came, 1989. I have 2 kids, a son and a daughter. They both are now grown and out of the house, fortunately. And one of them lives in Colorado near Denver, and the other, my son lives in Colorado, and my daughter lives in Wyoming. My daughter lives in a little town called Centennial, which is up in the mountains. It's about half an hour from Laramie. So it's a great place for my wife and I to visit and, be able to get into nature and that kind of thing. So anyway, I continue to live here with my wife, Sally. Other inhabitants of our household include 2 dogs and, until recently, 2 cats. One of them died recently, so we're down to 1 cat. And we also have an African gray parrot. Any of you know about African gray parrots? They're really smart. They're very good at picking up language, and so you have to be really careful about what you say around it. You don't want to run an Eddie Murphy movie with the parrot there, because it will pick up the language quickly. So we got all kinds of funny stories about the things the bird has said. Anyway, that bird is about 36 years old. And I'm not exactly sure how long African grays live, but it could well outlive both me and my wife. So we'll put it in the will, who gets it. So that's a little bit about my family. When I came to Doane, there was no physics program, and of course no engineering program. And I was the only physicist, and there were no engineering faculty at that time. And so my job really was to start a physics program, which I did. And so we were able to develop a physics program, and eventually had enough students where we could get a second faculty member in the department. And things continued like that for many years. And it must have been about five or 6 years ago that I felt the need for us to really look seriously at starting an engineering program here. We had a dual degree program. By the way, we still have a dual degree program. It's a 3-2 program where you stay at Doane for 3 years, and then you transfer to a large college of engineering, and you can finish up a BS in a specialized area of engineering in 2 years. We accept 1 year of credit back to finish out a Doane degree. Historically, it was easiest to do like a physics major at Doane, and then you do the BS in mechanical engineering or BS in electrical engineering at the College of Engineering that you transfer to. And it worked really well. It was kind of by having both a physics major and the engineering major, it kind of expanded your resume because they're complementary to each other. And by the way, like I said, you can still do that. If you have an interest in doing a more specialized engineering program compared with our BS in engineering, it is still possible to do the dual degree program. Most of our dual degree students have gone either to Washington University in St. Louis. Historically, we also had students that went to Columbia University. Haven't had many students do that more recently. Well, we had 2 students in the past 3 years, I think, that went to Columbia. And so Washington and Columbia, those are very prestigious schools, and so you are able to do the dual degree program with them. And we've had a number of students who would transfer to UNL, even though they don't operate a formal dual degree program, but we'll still do the transfer back a year of credit if you want to do that. And University of Minnesota. We had several students go there as well. So the point is that we did have opportunities for students to pursue engineering here, but I felt the need to really have our own 4-year BS in engineering program for a couple of reasons. Number one, the dual degree program is a 5-year program, and obviously that's more expensive than a 4-year program. And so I could see definitely that for students who, for whom money actually makes a difference, which is probably everyone. A 4-year program is probably better than a 5-year program. So that would be one reason. I just felt that would serve our student population very well. Secondly, I really thought that having engineering kind of in the center of a liberal arts and science traditional education would really be very powerful, because engineers are problem solvers, and the way the solutions you develop to a problem that involve people, and most engineering problems are going to involve people in some way, to develop those really, good solutions, you've got to understand the culture that you're in, all the social factors, oftentimes individual psychological factors. And so that kind of knowledge is just very important. And therefore, that's one of the things that we stress in our educational experience here at Doane University. And so I thought that it might sound kind of strange at first, but I really thought that kind of putting together the liberal arts experience with engineering was very powerful and would be helpful both to students, but also just to society at large. So we were able to get that started, and that's when we got some engineering faculty, Cale and Joel Tremont, and now Emelina are all part of the department. We still have a physicist, though, and I'm still very interested in encouraging students to study physics as well as engineering. And if anyone has a possible interest in kind of the more fundamental aspects of science, physics is definitely something to consider studying, major or minor, or at least take a few extra courses. Everyone here will be taking introductory physics, but I encourage you to take additional courses as well. I have done research with students for many years. Some of my research in the past was more physics education related, so developing curriculum materials, and we've had things that have been used nationally. And I was involved in some of the early work to develop computer tools for helping in the physics education world. More recently, in the last 6 or 7 years, I've gotten back to some of my original research interests, which involve using the computer to simulate different kinds of systems. In the past, I've looked at understanding how atoms in a solid move. So if you have diffusion in a solid material, I've done some work on developing computer simulation models for that. That's actually an important process in batteries, in the way batteries work. So it does have practical applications. And then more recently, I've crossed over into biology and have done work on developing simulation models for the growth of something called biofilms, which is just where bacteria cells attach to a surface, and instead of just floating around, they grow on a surface. And that's actually a very important area of study. And there's both positive and negative aspects to it. The negative ones are biofilms grow on parts of implants and bodies, and so you don't want them there. They're very hard to kill. They're not really susceptible to antibiotics. Actually, when you get cavities in your teeth, that's from a biofilm that's growing on your teeth. So everyone's probably got some biofilms in your mouth right now. So that's the negative aspect. The positive aspect is that we have now technologies that use biofilms to clean out toxic chemicals from water. And so that's an area that I've started to do a little bit of research in, and actually, Joel has been helping with that as well. And we've had students involved in all these different aspects. It's very interdisciplinary, so it's biology, but the underlying physical things that are going on are physics. It's diffusing chemicals, fluid flow, and stuff like that. And so it's definitely a lot of basic physics. And then when you're developing these bioremediation technologies, that's engineering. It's chemical engineering, basically. So no matter which area you like to pursue, there's opportunities for doing research in that area. If you have any possible interest in that, feel free to come on by and I can explain more. So I think that's probably enough for right now. Just really feel free to drop by anytime to just let me know more about what you're up to and what your interests are, and if there's any advice that I can give on your courses or life. Well, maybe, I don't know, maybe you don't want to take life.
I've taken a lot of advice from Chris on life, so.
I don't know if that's a good idea, but you're welcome to ask questions, and we can explore those things. So thanks, and hopefully I'll see all of you around.
Thank you, Chris.
Sorry.
It's all right. Okay, so again, thanks to Chris for that. Next guest we have is Dr. Joel Tremont. He is the chair of the Physics and Engineering Department. He and I have, he was here before me and after me, so interesting situation there. But I'll go ahead and give the floor to Joel. Okay. I'm going to stand in front of the camera. So.
Okay, yeah, I guess. I have a big tendency to move around a lot. Wide frame, I don't know. Okay, put this on here, I assume. Okay, all right. I guess I don't know if I've met any of you quite yet. Thanks, Kale, for having me over here. I guess how many of you are from Nebraska? Quite a few. How many of you are out of state? I guess that's a mutually exclusive there. Okay, so I always try and play a little guessing game, right? So I'm sure we've got maybe some small town Nebraska folks. So see if you can stump me. Who do you think is from somewhere that I won't be able to know in Nebraska? Any small towns? I got some doozies last semester.
Somebody from an exciting small town.
Come on. Stump me. Where are you from? Wilbur. Okay, yeah, Wilbur there. I was just at Frank's Smokehouse. From there, yeah, we got like $100 worth of meat. So if you ever want steaks or anything, Frank's Smokehouse. So that's pretty good. So what's that?
Or Carpet Shacks.
Carpet Shacks? I've never been there. Where's that?
It's on Main Street too. It's literally like a block straight west of Frank's.
Okay.
It's reopened.
Oh, did it?
For like 4 or 5 years and then.
Oh, okay. Yeah, I'll have to try that out next time. But yeah, went out for a Sunday drive yesterday. Anybody else? Okay. So for out-of-state folks, where might you come from?
I come from Georgia.
Georgia. Okay. Yeah.
California.
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 Ohio.
Ohio. Okay. Yeah. Kansas. Okay.
Tennessee.
Tennessee. Okay. I think we got Shane is from Tennessee as well. Okay. Anything else? Okay. So that's good. I actually like to see that. It's very diverse from there as far as locations from there. So I guess I'll tell you a little bit about myself, right? So I myself originally was born and raised here in Nebraska. From there, I went to UNL and I graduated with my bachelor's in chemical engineering, right? So my first educational experiences, right, in terms of engineering, as an undergraduate was really centered around really traditional chemical engineering. And that was kind of pointed that direction because in high school, hey, I liked chemistry and engineering sounded like fun. It seemed like I could maybe make some money doing that. So that's kind of how my life choices got steered in that direction from there. So after I got my bachelor's in chemical engineering, I worked at, if any of you are from Lincoln, is anyone from Lincoln? No? That's surprising. Okay. So there's Lincoln Industries, formerly Lincoln Plating. If you ever see like the Harley Davidson or the big Peterbilt semi trucks, all their chrome plating, right? So I worked as a process engineer for them for a few years, doing more traditional chemical engineering aspects of that. And while I was doing that, I was taking graduate classes part-time, and then I decided to jump in and do graduate school full-time. So as I got into my graduate work, I ended up doing more biotechnology-based work from there. So the specific project that I worked on as a graduate student Do they still have the show CSI? Maybe. Okay, you might be familiar with that. So if you ever go and you see that they collect the DNA from the crime scene, right, and they want to test that, right? Or if you think that you go into the hospital, right, and they want to have this rapid diagnostic test, right? So they want to test you on the spot. One of the processes, even if we look at like the COVID test, right? So the COVID test they do right now, they have either like the rapid antigen test, right? That's kind of more, less sensitive, but it's fairly cheap to do. The other test, right, is a PCR-based test, right? And the guy that developed the PCR process, Kerry Mullis, I think we've got like a book around him somewhere. He won the Nobel Prize for discovering this PCR process. And really what it's doing, it's taking, say, a small amount of DNA, right? So if you could even have a single copy of DNA from the crime scene, right? Or you have a really low-level infection, right? And what this process does is it takes that single copy and it replicates that, right? It copies that, right, to make 2 copies. And then those 2 copies become 4, right? So you have this, and those 4 become 8. So you have this exponential increase in the amount of DNA that you have so that you can detect, right, if you have, right, some type of virus, or, right, they can match the DNA to the crime scene. So that's really what I did in my graduate work from there, which is quite different from the, right, really traditional chemical engineering. But it was really interesting to see that, right, that biology process. I know Chris talked a little bit about biofilms. From there to see how we can take, right, either a biology or a chemistry process from something that you don't really normally equate with engineering, right? But we can apply these engineering principles, right, and these physics principles to these processes, right? So things like chemical diffusion, right? And that one was specifically related to heat transfer, right? So if we get the sample in, the process that it goes, right, it just takes the sample and it heats up to 95 to separate the DNA, and then it cools it back down to 60, right? And there's some other enzymes and stuff going on there, but it's really a cycle of heating and cooling, right? So we took the approach as engineers to say, okay, how can we take this process and use these engineering principles to make this as fast as it can go from there. So we took a process that would normally go from, say, an hour to do the run in the lab, right, to 10 minutes in the lab. From there. So that was really my graduate work. So after that, I ended up working in Omaha at Streck Labs. So the technology that we developed while I was in graduate school was purchased by Streck Labs up in Omaha. So I ended up working in their research and development really to commercialize that product even further. From there, so I worked there for 4 or 5 years. From there, and then I decided that, right, I was ready for something different. So what I did after that, I came back and I've taught at UNL. So I've taught back in the chemical engineering department. I was here at Doane visiting, I think in 2016, as Caleb mentioned. I went over to Nebraska Wesleyan for a year. And now I'm back at Doane. I think I've been back at Doane here for about 3 years now. So I'm glad to be back here. I really enjoy being able to talk with all the students, right, about these ideas, right, and to work on these engineering principles from there. So I know this first semester, I think many of you probably, it is your first semester here. It's certainly probably not been as expected, but hopefully, right, doing a lot of the face-to-face stuff, it's been enjoyable, right, from there. So I am in, and I forgot this last time, lead 241. So if you kind of go out around the corner, second floor, kind of in the side there from there. So if you ever have any questions, right, want to talk about anything, whether it be engineering, right, from there, I'm certainly not one to ask about life choices from there. So
I asked you about life choices.
no, I'd stay away from those. But yeah, if you have anything, need anything, hopefully your first semester has been going pretty good from there. But yeah, we're all here, both Kale and Chris and Emelina and myself, from there to help you through your engineering journey, right, from there. And then also if you want to pursue physics, math, any of those other majors as well, right? And I think that's one of the values of our program here at Doane, is that you get a lot of exploration, right? And you're not necessarily streamlined like I was, just straight chemical engineering from day one, right? We actually have some exploration into what might be the best fit for you in your career path there. So hey, I guess that's all I have.
Talk about some of the courses you teach.
Oh, okay, yeah. So most of you have me for 8 a.m. physics next semester. From there, so I teach basically physics 1. I taught, basically Physics 1, Physics 2. My main engineering courses are statics, thermodynamics, fluid mechanics, as well as some of the engineering research courses from a senior standpoint. So I guess some of the projects that I've worked on, I've helped Wentworth with the fluidized bed reactor with the biofilms. I've worked on a lot of analytical instrumentation, both from the DNA detection. I've worked a little bit on chemical detection through gas chromatography. I'm sure many of you are in the dorms. One of the senior projects that I worked with, I do teach, I guess, the environmental engineering. I don't know if anyone's interested in the environmental engineering emphasis, but one of the senior projects that I did with Dalton Fellows, right, was a solar aerator. And if you walk by Doan Lake, that's the little thing that's bubbling from there. There's the solar panels out there. So that was a senior project that I worked on. So, okay.
Okay. Thank you, Joel. I appreciate you coming.
Thanks a lot. It's back to here. I stayed still. I should get a prize.
I was ready to jump in and start tracking it down. Thanks, Joel. And we do have, as Joel had mentioned and as Chris mentioned, we do have another member of our department. She's unable to be here. I have a presentation from her. I'll actually probably be giving that. No, I'll show it to you. Let me go get my cable. I'll be right back.
I was gonna say something kind of.
I don't need niceties. I'm not here to be your friend. I know. My philosophy is it's hard for me to be your friend and then torture you. Because I do that as a professor. And that's my job. So, let me pull this up. So, all right. Okay. Now, Emelina was not able to be with us today, so she put me in charge of giving this presentation about her to you, so hopefully I do this some justice. Emelina is a recent hire to our program. As Joel had mentioned, she completes the last wing of our program, where Joel tends to deal with a lot more of the heat transfer, fluid systems, and then the fundamental engineering courses. I tend to deal with a lot more of the electrical engineering courses, mechanical engineering courses, this course, foundational engineering design courses. Chris Wentworth deals with a lot more of the physics courses and foundational knowledge courses. Emelina, on the other hand, is our resident civil engineer. Now from this presentation, you may not actually know that she's a civil engineer, but we'll talk about that a little bit. So there's Emelina. She's the one in the middle. What? That is also her, yes. This was on one of her blue days. She is from South America. She actually came from Brazil and moved here, I believe it was about 15 years ago. Don't quote me on that, but she came here to Lincoln to study. She originally got her, well, this is her hometown. This looks nothing like Lincoln, Nebraska. Some people, though, I guess they like moving to places where the temperature seems to drop below zero often. Some young pictures of her. She graduated with, she got her bachelor's in civil engineering from, I am not even going to attempt to pronounce that. I can speak Spanish, but I do not speak Portuguese. So that's, they're a little bit different, so I'm not even going to try. This is the school that she worked at. She was very used to being the only girl in her class. And the stories that she's told me, she's just very used to engineering is a very male-dominated industry. She then went on to the University of Nebraska, Lincoln, and graduated with her master's degree in engineering mechanics. She studied under a former dean of the college there. For her master's thesis, what she did work on was in crack propagation in concretes. She did a lot of work researching concrete as a material, that type of thing. Something I did not know until she sent me this presentation was that she had actually done a bunch of work with finite element analysis. Finite element analysis is something that happens to go very strongly with my background, so I was really excited to know that I'm not the only person who does FEA. And after she graduated, this is where she went. None of you are from Lincoln. Even if you were from Lincoln, you probably wouldn't recognize this view because that's not a common view. This is Duncan Aviation in Lincoln, Nebraska. Duncan is, they're a private-owned business. They deal a lot with airplane renovation, reconstruction, that type of thing. They don't deal a lot with building planes, but they outfit interiors, change interiors, put in new sensors. So there she is working with airplane people. Look, there's a hangar. I know she can give this presentation better than me. So one of the things that Duncan does is they take the interior of an airplane, which originally looks like this. They remove all of the existing. Was that carpet actually invented in 1970?
Yes.
Wow, okay. And those are kind of chairs that look like they may belong in maybe a Volkswagen van. And they change it to be more high-end. Now each of these furniture fixtures have to be acceleration rated to be able to handle the accelerations, to be able to handle basically the stresses that are put on it in aviation. They have a lot of stylistic trends that they do. A lot of this stuff is handmade. because you can't get custom furniture like this. You don't go down to Home Depot and be like, I just want an airplane couch. Gonna go grab one of those. So they have to hand make a lot of these materials, and obviously also improving the lighting, and just to give it a more comfortable feel, so that people who are from other countries or for big executives from businesses in our country have nice, comfortable planes to ride in. And they do a lot of exterior work and engine repair, engine fixing, painting. They'll do some jobs where here they took the tail fin and they applied a new finish to it. They put on some new systems. What Emelina did a lot of while she was there was she was work on cabinet design and the kind of structures that would go inside of the actual airplane and make sure that they were rated to be able to handle the kind of acceleration. So here's some of the plans for this particular cabinet design. It involved a lot of structural analysis. So while yes, she did have a degree in civil engineering, there was a lot of carryover into the aerospace industry. After that, she did a lot of work with certification. The problem with airplanes is that every single item in the airplane has to be certified for flight. Because if you have a single instrument that produces too much static electricity, it could ruin the entire airplane, cause the whole thing to crash. It's a major liability. So certification is key in these types of systems. And there she is with a whole bunch of men. Yep. And there's two other women, yeah. But still, male-dominated industry. And she had some interesting trips. Like here she went to the Great Wall of China. I don't know what these foods are, and I am not food adventurous. But she has got a lot of pictures here. This is a cave that is actually in Lincoln. I went there last year. Other trips she's had, there's her back at Duncan. She can give this presentation better than me. And she won an award for being 40 under 40 in aviation. So congrats to her.
What's that mean?
It means she is under 40 and she was one of 40 people selected that year to receive the award in aviation. Okay, so that was my best attempt at giving a presentation. And
I think it's something sense to do now that I work at Duncan Aviation.
you got the name going, right? Duncan and Duncan, there you go.
Never answer a phone call. Oh, this is Duncan again.
There you go. So the reason why I wanted to bring everybody in and give you some exposure is because this isn't just me. I may be your first professor in engineering and physics, but I will not be your last professor. We do have a rest of the department, and everybody has their quirks. I have a great amount of respect for the people I work with, not just in our department, but actually here at Doane in general. I really enjoy this college. As I told the morning class, I'm not here because I couldn't find another job. Lots of professors go into teaching because they don't want to go into industry. I did want to go into industry because I wanted to actually make money and not eat ramen for lunch every day again. Well, that didn't happen, and here I am. I had a Lunchable for lunch today, which that's high spending for me. I'm starving too. I'm going to go eat my chair after this. But I want you to recognize that this is a group effort. What I'm teaching you here in this class, a lot of it is me going off the deep end in front of you and you witnessing my slow spiral to chaos. But some of it it's something that we all share. we developed this program because we are passionate about education. We're all here because we're passionate about education. As Joel mentioned, Joel is the patent that Joel ended up working on and the device that Joel ended up working on is being used internationally right now because it was that innovative. But rather than sit back and go invent something else and build chairs out of money, Joel decided to go into education because that's something he's passionate about. Chris Wentworth is the same way. Emelina is the same way. I can tell you that we all took pay cuts in order to teach you. This isn't something that we're doing because we can't do something else. Emelina came out of Duncan Aviation, where she was very well loved and respected, and to come here and teach for this opportunity. I came out of UNL. I have 2 patents to my name, multiple international publications. I could have been hired anywhere. I'm here because I want to be here. I'm here because at the end of the day, I get to hang out with Duncan. Yep. And some of the rest of you, I guess. Yeah, sorry, he just sits closest to me.
We have to be close.
Yeah, and you know what? I just won't tell you anything. Yep. I continue to ignore you. It's all right. You are way too good of a spirit for this. So when I get fired, it'll be because I continue to look over Ivana's head. I'm sorry. I really do appreciate you, and some of the rest of you too. A little bit. I think I kind of know your names by now. So what I did want to say is one of the things that I think our department speaks really well about is that we all come from a very diverse background. Joel is a chemical engineer who his major contribution was in biomedical engineering. He has also done a lot of work with heat transfer systems, electrical systems, electronic systems. To say that he is a chemical engineer does him a disservice because he is an engineer who has done chemical engineering work, but also all of these other things. I have a background in mechanical engineering. If people ask me what kind of engineer I am, I say mechanical. But I am not just a mechanical engineer. I am a member of the American Society of Civil Engineers. Little known fact there. I have publications in a medical journal where I continue to get requests for follow-up discussions on urology because I helped redesign a urology procedure. I have all these things that go behind me that don't have anything to do with traditional mechanical engineering. And this is what our program is about. Engineering in general is not unidirectional. Physics in general is not unidirectional. So when it comes to looking at career choices, from most people from traditional schools will use the term, what kind? What kind of physicist are you? What kind of engineer are you? And it is important to understand the distinguishment there, okay? Major types of engineering is you've got civil engineering. What civil engineering is it's the design of static structures. These are buildings, roadways, waterways, how to deal with water treatment, how to deal with water flows, electrical structures, anything that's going to stand for a long amount of time without changing. That tends to be more civil work. You have your mechanical engineers. Mechanical engineering tends to be a lot more machinery, moving components, stress analysis, engines, vehicles, that type of thing, robots even. You got electrical engineers. Electrical engineers work on electronic systems, sensors, sensation, integrated AI systems. AI systems tend to be one of the bigger areas of research lately, kind of a hybrid electrical engineering, computer engineering type of thing. You've got environmental engineering, where here these types of engineers will deal with environmental impacts, study chemical analyses out in the environment, check soil samples, do a lot of ecological study. You have other types of engineering too, like aerospace, biomedical. I think I found a website once that gave me 52 different types of engineering. There's failure engineering, there's risk analysis engineering, there's process engineering, there's manufacturing engineering. I'm not gonna bore you by writing out every single potential different type of engineering. The issue with a lot of these is if you go look at people like Emelina, she worked here with this background. And she was fully capable of doing what she did. Me, I work here, but I also work here, and I also work here. So for me to say I am this is for me to say, well, I can't do those. The reality of the situation is that you will develop a set of skills that you can use in a broad area of just about anything. You aren't limited by anyone except for yourself. Okay, so when it comes to physics careers, a lot of physics careers tend to be a lot more research. You have the difference between theoretical and practical physics research. A lot of theoretical research delves into things like black holes, dark energy. We've had some of our students go and do research there at higher level institutions, go into academia in those sites. Physicists oftentimes are brought on staff to assist with quality assurance, do research on components, be able to study molecular compositions. Physicists tend to have a greater understanding of chemistry than the average engineer. I hate to say that, but they just tend to be the more theoretical knowledge based. And they do end up in a lot of research places as a result. So there's a lot of branches where you can go with either of these two areas. The foundation of what our program and what our department is set up as, Chris Wentworth really being the head of it, was that we want to make sure that you know what you're doing when you go out into life. As I said, I came here by choice, not by force. This wasn't my last option. This was my first option. I actually only applied to one job when I graduated, and I got that one, and now I'm here, torturing you. I didn't want anything else. This was where I wanted to be. Because I believe in the vision of what we're doing. Now, most of you are in hard classes right now. You may be in chemistry, which sucks in distance learning. You may be in calculus or pre-calculus. You are tasting what difficult math and difficult science is like. And I would like to tell you it gets easier, but I'm not going to lie to you. This is not your hardest semester. If you choose to go into our program, if you choose to go into our department, it does get harder from here. This is not a degree that anybody goes into because they want something that they just need a degree. Jace, you are the absolute antithesis of everything I'm about to say. Nobody, except for Jace, goes to college to get an engineering degree or a physics degree just because they have no other, they get a wrestling scholarship and they just needed to pick a degree, except for Jace. So it's not something for the weak of heart, okay? You go into this because you want to be a part of this. You go into these fields because you are willing to work. I was a standout high school student. I was slated to achieve no matter where I went. They basically told me, here's money, go graduate from a college because you're going to make whoever's college you graduate from proud. And then I became the rival to my college, so I guess, well, joke's on you. It's a funnier joke than it was. I need to work on my delivery. But the reality of the situation is, I should not have struggled in engineering. My undergraduate, it should have been easy for me. But I can tell you, I thought I was really dumb going through school because it was hard for me. I'm not a dumb guy. I play an idiot up here in front of class, but I'm really not that dumb. And the fact that I struggled it should be something that I would expect all of you to struggle too. If you do not struggle, you're better than me. You might as well get up here and start teaching. We do our curriculum so that you struggle, which means you don't have to be the smartest person in the room to do well in our department. In fact, if you are the smartest person in the room, you will struggle harder than everyone else because you probably haven't had to struggle before. I've had to deal with that with some students. Some of the guys I graduated with, some of the smartest guys I knew, quit engineering because they had to struggle, and when they had to struggle, they didn't know how to handle it. They didn't have the mental fortitude to be able to handle challenge. The best kind of scientist and engineer is not the smartest one. It is the one that works the hardest. If you are willing to work hard, you will do just fine in our program. If you're willing to put in the effort, if you show up to class every day, you hand in every homework assignment, you ask for help, you study, you spend time doing your research, you do the assignments you're told when you're told, you do all that work, you'll do fine. And this is a guarantee. This is a guarantee that I give you. We've had a lot of students go through our program who would not have survived a traditional engineering or physics program. Well, they graduated from here, and they're doing very well now because we gave them that opportunity to work hard. And in life, if you work hard, you usually get what you want. So I'm not going to sit here and say, you're all struggling in your classes, you're a bunch of dummies, kiss my feet. No, I will say this, if you're struggling, it's a good thing because it means you're growing. If you go into college, you get out of college, and you never struggled at all, why did you waste your money? Because you could have done the same thing before you ever went to college. My job is to make you struggle. Maybe not in this class. This is the easiest class I teach. But it is eventually to make you struggle. Okay? Keep that in mind. So before we leave, I know I'm a little bit over class. I apologize. Classes you should take next semester. If you are in calculus right now, next semester, take math 335. Okay? If you're in pre-calculus right now, next semester, take math 235. You should be sure, if you are in either of these, you end up in a math class. You have to keep up on your math in order to stay in our program. I want to graduate you in 4 years. As much as fun as it is keeping you around, I would rather not. You're spending a lot of money to be here. Other classes you should take next semester. CST 210, Foundations of Computational Science. EGR 210, Fundamentals of Engineering Design. I teach that class. And Physics 201, General Physics 1. Okay, if you have extra space in your curriculum, you want to take another class, go for it. But these three, with one of these, is a lot of credit hours already. Yeah. Yes, and it's going to be a hard semester again. And then it gets better from there. No, it doesn't. I lied.
Yes.
Ah.
Do we not need Chem 126?
Don't take it next semester. Yeah, I mean, you can if you want to, but it actually gets easier the later on in your curriculum you get.
Chemistry does?
Yes, because you learn about energy and everything that has to do with energy in your other engineering classes. From what I've heard from every engineer that has taken our program, that took chemistry freshman year and took it again junior year, is that Chem 126 is cakewalk because you already know the stuff. You just learn it in an engineering environment or a physics environment or all of that. Okay, any other questions for me?
So, what do we do about that?
What do you do about this?
Yes.
Contact your advisor. You should, your advisor should work with you to set up your schedule. I believe that's Rhonda Lake for all of you. You can email her and ask to meet with her to talk about classes. Otherwise, all of this is done through WebAdvisor. I think they're going to help you out with that.
So there's got to get approval for it, right? So we get the approval.
On WebAdvisor, if you click request advisor approval, they can sign in. Then, yeah. I believe you guys sign up for classes next week.
Sick.
Yeah, so it's coming up soon.